Okay, so first thing we're going to start with, and this is just a very small review. You guys should already know this. But what law says the substances before a chemical or physical change should equal the substances after a chemical or physical change? Anybody remember that? What law states the mass before a chemical or physical change should equal the mass after? Anybody remember? Oh my gosh. Close. The law of
conservation of mass.
Thank you. You just made my day. I got half. Very good. So, quick reminder, law of conservation of mass. And there we go. Okay, law of conservation of mass says mass before and after a chemical reaction. RXN means reaction. I use that a lot, just it's easier to write. Mass before and after a chemical reaction must be equal. So, in order to represent the law of conservation of mass, what we have to do is we have to balance chemical equations. Now again, a chemical equation or a formula equation represents a chemical reaction, okay? We have to show that the mass before and after the reaction is equal, okay? And we do that by using coefficients. Coefficients are whole numbers. Do I need to make that bigger, or are you guys okay? Okay. Coefficients are whole numbers that are written before a chemical formula. So, for instance, if I have 2H2O, okay, this is a coefficient, okay? This coefficient tells me I have 2 water molecules. This 2 would also tell me I have 2 times 2, I have 4 hydrogen atoms. 2 times, I have to pretend there's a 1 right here, 2 times 1 would tell me I have 2 oxygen atoms. Okay, so a coefficient will only ever go in front of a chemical formula. I would never, so let's say for instance I have NaCl, okay? I would never try and stick a coefficient in between the two of them, okay? Because sodium chloride is a compound. If I need more of those formula units, I could put a 2 in front of the NaCl, and that would tell me I have 2 sodium chloride units, okay? Or it would also tell me that I have 2 sodium atoms and I have 2 chlorine atoms, okay? So what we do is we use these coefficients that we write in front of our formulas to show the law of conservation of mass, okay? So let's go ahead and let's just jump into a few of these problems. Now, don't write the actual word problem down. You guys are going to write the formula problem down. So we're going to start with this one that says hydrogen gas and oxygen gas react to produce liquid dihydrogen monoxide. So we're going to start by writing the formula equation, okay? So what's special about hydrogen if he's all by himself? Good, we have to have a little 2 next to it, right? So hydrogen gas, so I'm going to start with H2. And it says it's a gas, so I'm going to put a lowercase g next to it. And is what sign? Plus. Oxygen gas. So oxygen is special, is diatomic, so I got to put a 2 next to it. gas is G, reacts to produce, that's my arrow, liquid dihydrogen monoxide. What's dihydrogen monoxide? Yay, H2O, H2O, and it tells me it's liquid. Okay, so we always have to start there. Start with the correct chemical formula. Now what I'm going to do is I'm going to look to balance it so we can uphold the law of conservation of mass. If you are and this one's a real simple one, we're just starting very simply. If you are mathematically inclined, you might not have to write everything out, okay? I'm going to show you how to write everything out to get things organized. If you can look at the chemical equation, and if you can put the coefficients where they need to go to balance it out, knock yourself out. Okay, I'm just going to show you how to write it out, how to organize your work, and if it works for you, great. If it doesn't work for you, don't use it. Okay, it's not required. I would say the times that you might need it, especially is if you have a lot of elements and a lot of polyatomic ions to kind of keep everything straight. Okay, Lauren. Let me guess, Kennedy Dawson.
Nope.
Not today. Tina! That one's for you then. Okay, so I'm going to start on my reactant side, and I am going to write out the elements that I have present on each side. And I like to keep them in order on both sides. So these guys are my reactants. This is my product. Okay, so I'm going to count up how many hydrogen atoms I have. I have 2 hydrogen atoms. I have 2 oxygen atoms. Okay, on my product side, I have 2 hydrogen atoms, and I have 1 oxygen atom. Now, if I had equal amount of each atom on both sides, it would be balanced, and bless you, and it would show the law of conservation. Okay, right now it's not balanced. Okay, our hydrogen are good, but our oxygen needs fixing. Okay, if I have 2 oxygen here, I'm going to try and get 2 oxygen here. Okay, I can't add subscripts. My formulas are already set. Okay, the only thing I can do is I can add coefficients. So I could put a coefficient of 2 right here. Now that 2 applies to everything behind it. Okay, that tells me I have 2 times 2 now gives me 4 hydrogen. 2 times my 1 right here gives me 2 oxygen. So I fixed my oxygen, but now my hydrogen has changed. Okay, so now what I can do is I'm going to go back to my reactant side, and I'm going to fix my hydrogen. If I have 4 hydrogen here, I'm going to put a 2 right here. 2 times 2 will give me 4 hydrogen. So now my hydrogen are equal on both sides, and now my oxygen are equal on both sides. So now my chemical reaction or my formula equation is showing the law of conservation. Okay? Let's go to one that we did 2 days ago. Okay? You guys should have this one, solid aluminum. So look back in your notes. You had solid aluminum. Reacts with aqueous copper 2 chloride to produce solid copper and aqueous AlCl3. Now, hopefully you can see why now it is really important to have your formulas correct. Because if your formulas are correct, when you try to put coefficients, things are going to be off. Jenna, that's for you. Okay. Did you guys find the equation from the other day? No? Can you see that, Issa? Yeah. Okay, so let's go ahead and list our elements out. We have aluminum on this side. We have copper on this side. We have chlorine on this side. And we'll always have the same elements on the left-hand side as the right-hand side because of the law of conservation of mass. You can't just have a different atom or element pop up that isn't already in your starting substances. So aluminum, copper, chlorine. I have 1 aluminum, I have 1 copper, I have 2 chlorine. On this side, I have 1 copper, I have 1 aluminum, and I have 3 chlorine. So what needs to be fixed? Chlorine needs to be fixed. Let's start on this side, okay? Because right now we have a 2 and we have a 3. So a number that is common to 2 and 3 that they can both divide into evenly would be 6. So let's try and get 6 on each side. So in front of my formula over here, I'm going to put a 2. Now that's going to change my chlorine, which is great. 2 times 3 is going to give me 6. But that also changes my aluminum to 2. So now let's move to the other side. Let's go ahead and fix chlorine. Coefficient that goes in front of the copper 2 chloride. What am I going to put here? I'll put a 3 here. That changes my chlorine. 3 times 2 is 6, so that's great. But that also changes my copper to 3. While I'm on this side, let's go ahead and fix aluminum. If I have 2 aluminum here, I have to have 2 aluminum here. I'm going to put a coefficient of 2. I got one last thing to fix. I have 3 copper on this side, so I got to move to this side and get 3 copper. So I'm going to put a coefficient of 3 here, and that gives me 3. So I've got 2 and 2, 3 and 3, 6 and 6. And we always want our coefficients to be the lowest possible numbers, okay? So if you put coefficients in, let's say you put 4, 6, and 4. If you can divide all of those by 2 and still have the equation balanced, you need to do that, okay? Coefficients should be as low as possible. What do we think? Do you guys remember doing this in middle school, maybe? Nope? Okay. Well, I know we didn't do it in physical science because we were rudely cut off by COVID. Let's do this one. You guys don't have this one. This one, the formula equation is already given to you. So, there we go. So I'm going to give you a second to write that down. So NH3 plus I2 yields N2I6 plus H2. So we're just going to balance this one. Okay, I'm going to go ahead and I'm going to list my elements on each side. I have nitrogen, I have hydrogen, I have iodine. I'm going to have the same over here, nitrogen, hydrogen, and iodine. I have 1 nitrogen here, bless you. I have 3 hydrogen here, and I have 2 iodine here. On this side, I have 2 nitrogen, I have 2 hydrogen, and I have 6 iodine. So this one's kind of jacked up. Where do you guys want to start? What element do you think we should start with? Louder? NH3? Start there? Okay, Carson, what do you want to put in front of this? Put a 2 here? Okay. So that's going to change nitrogen to 2, and it's going to change hydrogen to 6. Right? 2 times 3 gives me 6. Now, where do you want to go? Put a 3 on H2 on my product side. Awesome. And that's going to give me 6 hydrogen. Where now? Okay. The 3. That gives me 6. And he successfully balanced our equation. Not too bad? Okay. I want to look at one that we did yesterday, or 2 days ago. That is already in your notes. I mean, and if you're more than welcome to rewrite it out. Let me see if I've got it here. I want to look at balancing with polyatomic ions. There's 2 ways you can do this. Here we go. Okay, so you guys should have, oh, there we go. You guys should have this in your notes already, but I just think these 2 are switched, okay? Or you can write it out if you want. It's totally up to you. But we converted this equation from words to formulas the other day. Okay, so all through my schooling, I was always taught to take every single individual atom and balance them separately. So calcium, oxygen, hydrogen, aluminum, sulfur, and oxygen, okay? That is definitely one way to do it, okay? You can also, if you clearly see polyatomic ions present, you can balance them as a polyatomic ion. Okay, so let me show you. So I could, I'll give you one other example after this. So I could say we have calcium, we have hydroxide, we have aluminum, and we have sulfate. Okay, so this is one way to do it. Or I could break all the elements up. So on this side, I'm going to have calcium, I have hydroxide, I have aluminum, and I have sulfate. So on this side, I have 1 calcium, I have 2 hydroxides, I have 2 aluminum, and I have 3 sulfates. On this side, I have 1 calcium, I have 3 hydroxides, I have 1 aluminum, and I have just 1 sulfate. So where do you guys want to start? Okay, so do we want to focus on hydroxide then? Okay, so what coefficient will we put here? Put a 3 here. That is going to give me 3 calcium. 3 times 2 gives me 6 hydroxide. Where to next? So aluminum hydroxide on this side. What do you want to put right here? Put 2 here. That's going to give me 2 aluminum. That is going to give me 2 times 3. That's going to give me 6 hydroxide. Still need to balance out sulfate and calcium. So 3 right here. So I'm going to have 3 calcium. And that gives me 3 sulfate. Okay. So when you are dealing with polyatomic ions, that is definitely one way to do it. Okay. If it's easier for you to list out every single element, you can do that as well. Okay. I want to give you just one other example to show you that. Or just let me give you one other example. Because sometimes you're forced to break out all of the elements individually. I think we did this one together. I don't know if we did this one together or not. Okay, let's just do this one. So we have the decomposition of solid ammonium dichromate. I think we did this one together, didn't we? So ammonium is NH4. Dichromate is Cr2O7. Ammonium is +1. I think dichromate is -2. Right. Thank you.
Appreciation Week. Have a great
Thank
Friday.
you. Somebody check your polyatomic ion list. Make sure dichromate is -2. Okay, cool. So do I need more ammonium or more dichromate? Ammonium. So I'm going to put my parentheses around it, put a subscript 2. So it says yields. So I'm going to put my arrow. 2 gaseous products. It's going to give us water, which we know is H2O, and he's a gas. And is plus. Nitrogen, what's so special about nitrogen all by itself? Subscript 2. And he's a gas as well, so I'm going to put G. And a solid product, chromium 2 oxide, or chromium 3 oxide, excuse me. So chromium is Cr. That Roman numeral tells me +3. Oxide is O, and he's -2. So I need a 2 here, and I need a 3 here. So the first thing you do when you do these, and you're going to have a mix. You're going to have to convert to formulas, and then sometimes I'll just give you the formula equation, and you just have to balance, okay? But it is really important that your formulas are correct. Once they're correct, you can't touch the subscript. The only thing we can do is add coefficients. That's it. So this is one of those ones that, can you see we have 2 polyatomic ions on this side? Okay, but they are not intact on this side. Does that make sense? Okay, so even though we have polyatomic ions, we can't group them as a polyatomic ion because they're not intact on this side. We have to break the elements down individually to balance it. Okay, so I would have to say I have nitrogen, I have hydrogen, I have chromium, and I have oxygen. So how many nitrogen do I have on this side? 2. Very good. That subscript 2 belongs to everything or is applied to everything inside. So like in math, you have to distribute it. Okay, so we've got 2 nitrogen, and how many hydrogen? And chromium? And oxygen? Very good. You guys are rock stars. Let's do the same thing over here. Let's do nitrogen, hydrogen, chromium, oxygen. We have, this one's side's a little easier. We've got 2 nitrogen. We have 2 hydrogen. We have 2 chromium. And we have 3 plus 1 oxygen here is 4 oxygen. I'm counting all of them up on that right-hand side. So where do you guys want to start? What element should we start with? Hydrogen. Okay, so what do we want to put right here? 4. Good. So that's going to give us 4 times 2. That's going to give us 8. But that changes my oxygen. So I have the 4 right here plus the 3 right here to give me a total of how many oxygen? 7. That worked out very well. Do we have to fix anything else? You guys are rock stars. Very good. So I had planned on classifying, but I think we'll stop right there today. Okay, we'll do classifying on Monday, which we'll just write them out like this, but we'll just tackle one thing at a time. Questions on this? Seems doable? Very good. So this is what I'm going to do. I want to give you guys a break, okay? And then I want to go through yesterday's assignment, make sure your formulas are correct. And then that's what you'll do the rest of the hour, is just that one assignment. Okay, I had something else scheduled, but I'll